All right, so moving on to question number 8. So question number 8 is also kind of interesting because it really is not heavy duty math. It really just is based on the understanding of how G is derived. All right, so let's go ahead and start with this. Okay, so I am going to do this part first, which is trying to compute G of 2144 using K, 21, 44, and constants, and then just additions, subtractions, and whatnot. Okay, so let's go ahead and work with this. So we'll go ahead and say on the diagonal scan line that has 2043, there are, let's see, 20 more pixels to go before reaching the end. And how do we know that? Because um, as we do the scan line, as we progress, x decrements. And because x is still 20 at this point, then we have 20 more pixels to go, because the next one is going to be 19, and the next one is going to be 18, and it has to go all the way down to 0 when it reaches the end. So we have 20 more pixels to go before we reach the end. Then we start the next scan line, the next diagonal scan line at, this is going to be, so the scan lines have a sequence number that is the addition between the x and the y coordinate. So in this case, the previous scan line, the one that I was on before, is on 63. So this one is at 64. So it's going to be 20 plus 43 plus 1 equals to, what was it again? 64. And, oh, um, that should not be, that's not how it's supposed to go. All right, so the x coordinate is going to be 64, and then the y coordinate is going to be 0. There we go. All right, so this is at the base of the entire scan line, and then every time we scan one more pixel, we are incrementing the y and decrementing the x. And you can see the y is currently at 0, and we need it to be at 44. So now we say there are 44 more pixels to go before reaching 2144. Oh, we are actually adding one this way and adding one this way. Yep, okay. So, okay, so I am confusing myself here. So there are actually two scan lines in between. All right, so that's okay. So we can say there are 64. Let's see, we go from 0 to 64, so there are 65 pixels to exhaust this scan line. And then on the next one, then we start the next scan line with a sequence number of 65. That's right. Okay, so this is at 65. The base of the scan line is at 65, 0, and it will take let's see, 44 pixels to reach 2144. So this means the G value of 2144, okay, 2144. So we have G of 2144 starting at the g of what is given to us, which is g of 20, 20 and 43. So we first have to add the 20, and then we have to add the 64, which is 20 plus 43 plus the extra 1, and then we have to add the 44 and then the plus 1, because it goes from 0 and then to reach that. Oh no, plus 44 is correct. There we go. And so we're only supposed to use k, this is k here. So we transform this one just to mention k, and we can only use 21 and 44. So we have 44, and then we have 21 plus 21, and we are allowed to use constants, so we just use a constant of subtracting 1 to account for the 20 that we had before. So that would become k plus 2 times 21 plus 2 times 44, and then the whole thing minus 1. Now this can actually be derived as well using, let's see, this can also be derived using searching for the word, using algebra. That's it. So you can actually use algebra as well, because you can basically spell out what is g of 2144, and then use algebra to get back into g of 2044, and then whatever is left, okay, use the constant, and then you just have to express that constant using 2144. Alright, so to get to this one, it's going to be a very similar kind of reasoning. So we say on the diagonal scan line that has x, y, there are, let's see, so we have x plus 1 more pixels before reaching the end. The next scan line starts at, let's see, so we have y being 0, so x is maximized. So we have x plus y plus 1 and 0, and it has x plus y plus 1 plus 1 pixels on the diagonal line. Then we get to the diagonal scan line that has x plus 1, y plus 1, but to go from, let's see, x plus y plus 1 plus 1 plus 2, 0, to x plus 1, y plus 1. There are, so we increment y each time that we go up, so there are y plus 1 pixels to reach x plus 1, y plus 1. This means g of x plus 1, y plus 1 is k, which in this case is defined to be g of xy. So we got that, and then we are just looking at the offset here. So we got the x plus 1 from here, and then we have the x plus y plus 1 plus 1, which is the scan line that does not contain that's in between the two scan lines, one containing xy and the other one containing x plus 1, y plus 1. So this is the number of pixels on that specific scan line. And then we have the extra one, which is y plus 1. So we have to add the y plus 1 over here. So once we reorganize things a little bit, then we end up with, well, this is just as good because it has already met all the requirements of using x, y, and then constants, because we just have a bunch of ones here. And then we just have a lot of additions. So that meets all the requirements already. I think that answers the question, which means, I might have made a mistake here. Let's see. I'm just double checking. Because if I plug in, okay, this is x plus 1, x plus 1, y plus 1, and then that's just y plus 1. So I don't think I need this minus 1 here. That is the answer right there. All right. Well, I might have missed some details here. Because to double check, you can always apply G again, just for double checking, as long as your solution, your final solution here, does not involve, another G. Well, you cannot use G. You can use K, but not, the actual application of G. So as long as you can always double check it, if you're only off by 1, then you can just, kind of find out, where you miscounted by 1, and, make up for that. So that's sort of the answer of question number 8. And I am going to stop recording and release it.